Hey everyone, this is Steve Bishop from ProgrammingMadeEasy.com and of course Gartman Technical Services. And today I've got some really exciting news for you guys, and honestly I have to cop to something I have been wrong about for 5 years. I've been totally wrong about this for 5 years, and I feel terrible about it because I've given some pretty bad advice based upon what I thought I knew. So I have to really apologize to everybody who I've given this bad advice to. The big thing that I've got to cop to is I was under the impression, sorry, my little wristwatch went off there. I've been under the impression for the last 5 years that VBA and Access did not have inheritance. And I didn't even understand what inheritance was when I first kind of heard about this keyword I'm going to talk about a little bit later. But for the longest time, I just was under the impression, I'd heard it from other places, that VBA did not do inheritance. And that was one of the main reasons why it was not a genuine object-oriented programming language. And it turns out that's completely wrong. It's completely wrong. There is inheritance. And in fact, there are abstract classes, things called interfaces. So this abstraction, the ability to inherit classes from what we call interfaces and create these abstractions called interfaces, means that VBA is a viable object-oriented programming language. It changes everything. It's a huge game changer. And a lot of you guys probably don't understand. You don't really quite comprehend, you don't grasp why is this such a big deal? Why is object-oriented programming even such a big deal? And I'm going to cover a little bit of that a bit later. I'm going to actually do a demonstration of the interfaces in VBA because I think this is just so cool. You guys really need to know about it. But before I get started on that, I wanted to give some really mad props to this little plugin here that you see on the screen called Rubberduck. So I was asked a question in one of the comments of my videos about object-oriented programming concepts, and I was about to give my boilerplate answer. Actually, I did give my boilerplate answer of VBA doesn't have object-oriented programming. And it prompted me to just do a quick little bit of research here, and I came across Rubberduck because I saw some of their blog posts and stuff, and it made me think a little bit about object-oriented programming. And they were stating you could do object-oriented programming in VBA, and I was like, well, wait a minute, that doesn't make much sense. So I went and checked out their website, which is this Rubberduck add-on, and it turns out this Rubberduck add-in is completely free. Okay, it's an open source project. It's completely free. You can find it out on GitHub. You don't have to you have to go to GitHub in order to download it, but it's really easy to do and install. But here's some of the things that Rubberduck has, and I just have to give them mad props because there's some stuff in here that I wished I had known about for the last several years with VBA and Access. If I had known about these things, I would have been implementing these practices a long time ago. First and foremost, this one here, unit testing. Wow, unit testing in VBA? This is huge. That's another big game changer. I could do test-driven development. I could build my tests and then build the code to implement the test or to fulfill the test requirements. I could do real genuine test-driven development in VBA. That is crazy to me. I did not think that was even possible. Up until today, I didn't even think you could do testing. I mean, I knew there were some asserts and stuff like that, but I never really thought about doing testing in Access. Everything was just kind of manual testing. So the fact that I could do unit tests, which means I can create code that tests other code, right? You create code that checks to see if other code works, okay? So unit testing is huge. That's a big one. Code inspections, there's a lot of add-ins for VBA and Access that have code inspections, but this is a really nice thing. But this was what drew my attention the most, was this refactorings part when I saw extract interface. Extract interface. Now, those of you who just do Access, interface doesn't really mean anything, but this is a huge keyword in .NET and Java and other programming languages. Interfaces are abstract classes, And we'll talk about abstract classes in depth a little bit later when I actually show you a demonstration of this. But essentially, an interface is like an abstract class. Interfaces are a type of abstract class. And essentially what interfaces do is they form what we call a contract. They say, I'm going to define what members a class should have in it, but I'm not going to tell you how those members are supposed to work or what they're going to really do, okay? All I'm going to say is that any class that implements this interface must have this property and this method, this property, this function, or this subroutine, or multiple of those. You can have multiple properties, multiple functions, multiple subroutines defined within the interface. But essentially, the interface is saying, I don't have any code that tells you what these functions are going to do or what these properties are going to do in the back end. All I'm going to tell you is that anything that implements me must have this property, this function, and this subroutine in it. Okay, it's creating a contract that a concrete class must use those methods. Okay, I hope everybody is following with me there. Now this is really important because now what you can do is, with that, you can have multiple concrete classes that implement the same interface. So you have one class that implements those same members that are defined in the interface, and then you have a different class that implements the same members from that interface. So you have two classes that are essentially interchangeable because they have the same methods and properties defined on them. So you can swap them out. You can have one in one case and another in another case. So you can write into code swappable classes without having to do any actual concrete changes within your code. This is really, really important. This is really big. This is a lot. This is what really kind of object-oriented programming is all about getting to. It's the main reason why you do object-oriented programming, is to be able to do this swappable code changes, to be able to take one piece and swap it out with another. So big implications to this. So I just kind of want to real quick here also show you this one here about Rubberduck, and then we're going to get into some code. This is probably, if of all those other things, unit testing, being able to refactor out to interfaces, all that good stuff, that's great. But source control, and hopefully this comes up in a good amount of time, but source control, legitimate source control in your Access code, this is huge. This uses GitHub. So those of you guys who are not familiar with it, go research it, GitHub. It's a way to do repositories of code where multiple people can work on the same project at the same time, and then you have a way of merging all those different pieces together in what we call conflict resolution. You resolve all the conflicts if there's anything that might not work. But this means you can take multiple, you don't have to have just one file that everybody's working on to make changes. Instead, you can have multiple people working on the same project and then later bring those changes together and merge them into one file. That's huge. That is absolutely huge. Being able to do that with your projects means that no longer are you confined to a very small group of people that can work on your projects. This means you can have thousands of people potentially working on the same project at the same time. Developers don't usually work like that, but theoretically you could have as many people working on a project as you want, and then you just have to merge all those changes together, and source control gives you this. And the other thing about source control is it's really a backup system. It's a way of backing up your code to a server, to the cloud. So you can make your changes and store them locally, and then you can save those same changes up to the cloud somewhere, and then other people can get to that source control and they can put it on their own system. This is huge. This is a big deal to be able to do source control in VBA, and I have been looking for a utility that can do source control in Access, and up until now I had not found one that was very good. There were some old source control versions in like 2003 of Access and earlier, but this is exactly what I've been looking for, something that actually implements GitHub and does genuine repositories and being able to clone and do the conflict resolutions. That's amazing. And if for no other reason, getting Rubberduck this would be it, okay? If it weren't for all the other things, unit testing is great and everything, but being able to do source control is probably something I imagine a ton of you guys out there had no idea that you could do, and now your mind is probably just about as blown as mine is. So do it. Go get Rubberduck. Try to work out the source control stuff. Learn about it. You know, there's source control getting started so that you can learn more about how to do it. But this is fantastic. So anyway, mad props again to Rubberduck. Thank you so much for putting out this wonderful free tool for us VBA developers. Good on ya, as they say in Australia. So let's get to some actual code, and let's talk about interfaces and abstract classes. And let's see an implementation of this and why it's such a big deal to me. So let's start out first and foremost in the Visual Basic Code window here. I've got nothing in here. This is a blank database. There's no tables. I even deleted the basic one that comes out. I've got no classes, no modules, no nothing at this point. I'm going to go ahead and create a new class though, okay? And if you guys don't know what a class is, oops, I hit the wrong button, didn't I? If you don't know what a class is, I recommend that you go to my programming series, the basic course in Access 2013 programming and Visual Basic, and go understand and learn what classes are from that video first before you really are going to understand this. So I'm going to go ahead and create a new class module, okay? And on this class module, I'm going to create a public sub, and I'm going to call this dummy message. And it's going to return it's supposed to be a sub, or it's supposed to be a function, not a sub, I'm sorry. Function dummy message as string. Okay, so calling this function should return some sort of string. And let's say I'm going to define this. I'm going to take dummy message, and I need to assign it a value that it's going to return. So that would be, I am such a dummy, because I feel like a total nincompoop for not knowing that you could do inheritance in VBA. For 5 freaking years I thought this. I can't believe that I did not know this, and I didn't even bother researching it more in depth to understand. This is huge. Sorry, gushing. Okay, so I'm assigning this string, I am such a dummy, to the response that's supposed to come back when this function is called. Okay, very simple, very basic thing. I'm going to go ahead and save this as dummy message class. Okay, so I have a class. It implements one method called dummy message. So this here is called a method, for those of you guys that don't know. This public function dummy message is what we call a member of the class called dummy message class. All right, so that's all saved. That's all fine and good. Now, let's say I'm going to go and create a new module to consume this class, something that's going to use this class. So I'm going to create a new public sub called display message. Okay, and all it's going to do is it's going to pop up a message box that needs to show some sort of message. Now, in order for me to get to the message that exists here, all I need to do is create a new instance. So I'm going to do dim my message as, I'm going to say new dummy message class. Okay, and then from there, excuse me, I'm going to say my message dot dummy message. So I'm calling the dummy message function, and that's going to return back the string, I am such a dummy, okay? And that'll be displayed on the message box. Okay, very simple, very easy. Let's go ahead and save this module. I'm going to say messages. I'm just going to call it messages. Okay, so that's the name of my module, is messages. Now, all I have to do now is I'm going to actually use this display message. So I'm going to call display message, and that should give me a pop-up box that says, I am such a dummy. Okay, very simple, very easy to do. I'm using a class called dummy message class. I'm getting the value from this dummy message function that returns, I am such a dummy. That then gets displayed right here as part of my message box. Easy, right? Okay, now here's what I'm going to do. I'm going to go back to my dummy message class, And I'm going to click on this ready button. And what this is going to do is this is the Rubberduck's way of kind of just going through and parsing all the code that I have in here, because it can then find out and discover that I have this new class. And now from that, I get this context menu where I can go to Rubberduck and I can say refactor, extract interface. Okay, and this is going to do a lot of work behind the scenes for me. So I'm going to do that. Pops up this little box that says, what do I want to name this interface class? iDummyMessage class. So typically interfaces are, the naming convention for interfaces is to start the class name with an I, with a capital I. So that's good. I'm going to call this iDummyMessage class. Now, what are some of the members that I'm going to define on this interface? Well, I only have one right now, and I'm going to say function dummy message as string. Okay, so it's going to now go and create this new iDummy class, iDummyMessage class, and I need to move this around because this option explicit's not really right. We need to move this. This is a little bug that they have in here. I need to move that up to my declarations section. But notice on the iDummyMessage class that all we have is a definition of a public function. It does not actually have any code behind it. It's just a public function, returns a type of public function called dummy message, returns a type of string. That's the end of the function. Okay, there's no code. There's nothing in between the public function and end function. And that's what you want. You don't want your interfaces to do any actual code. They just define the members. Okay, so we're going to save this because I did make some changes there. I moved the option compare database and option explicit. Now, one of the other things that happened was you'll notice that there has been this addition up here to the dummy message class called, it says implements iDummyMessage class. So this implements keyword tells VBA that this class called dummy message class uses or implements those members that belong to iDummyMessage class. So essentially, I'm explicitly saying that this dummy message class must have the same members on it that are expressly defined by the iDummyMessage class. So sure enough, we have this dummy message method that is a public function called dummy message that returns a type of string, and that matches what we have defined right here. Now, I will run into a bit of a problem if I try to compile this at this particular point, and that's because VBA has some syntactically kind of goofy things to it. But if I save everything, save all my changes, I hit debug, compile, I'm going to get this object module needs to implement dummy message for interface iDummyMessage class. So this probably doesn't make sense the first time you see it. Essentially what's going on is the syntax for VBA is wrong. And the simplest way to solve this is I'm going to go up here to this little drop-down box for the object, and I'm going to select iDummyMessage class. And that's going to automatically create a private function, which it should be public actually. So I'm going to change this to a public function of iDummyMessage class dummy message. Okay, and now I'm going to move this code that assigns the value from the dummy message function to this one called iDummyMessage class underscore dummy message. And I can go ahead and delete this public function here. Now, since the name of the function has changed, I need to also change where that assignment of I am such a dummy the value that it gets assigned to needs to be changed to iDummyMessage class underscore dummy message. So we'll just save that. Now let's debug again, and we're going to have another method problem, and that's because I implemented dummy message class and we just changed the function name, right? So it's no longer going to work as dummy message, it's going to be iDummyMessage class. Okay? So because I changed, right? Because I changed the name of the public function, then of course I need to change it here when I call it in my display message subroutine. Now with all of those changes, let's try debugging and compiling one more time. Everything is good. If I hit display message, again, I am such a dummy. So it doesn't really look like I've done anything different, right? I haven't really made any significant changes to my code. It seems like I've just done a lot more work in order to make this happen, right? It seems like, gosh, there's really nothing special that I've done. Well, here's what I can do, and this is going to be really, really cool. Instead of saying the my message variable is a type of new dummy message class, instead I want it to be a new instance of iDummyMessage, and I need to get rid of the new because I'm not instantiating an instance of an interface. Okay, I'm just defining the variable to be a type of iDummyMessage class. So this myMessage object, or this myMessage variable, is a type of iDummyMessage class, which means any class that implements iDummyMessage class can be assigned to this variable called myMessage. Okay, so to do that, I'm going to use the set keyword, and I'm going to set myMessage equal to new instance of dummy message class. Okay, so all I'm doing is I'm defining my myMessage variable as, instead of a concrete class, I'm saying it's some sort of instance, some class that implements this iDummyMessage interface. Okay, now I'm finally setting that myMessage to an instance of a concrete class called dummy message class. Now I need to make one other change. This iDummyMessage class, if we look at it again, the function that it defined is just dummy message, not this iDummyMessage class, because now again, if I try to compile, it's going to say there's a method or data member not found. That's because the interface doesn't define that function as iDummyMessage class underscore dummy message. Instead, it goes back to just using the dummy message. Okay, so now I have an interface being assigned, or this myMessage variable is a type of iDummyMessage. I'm setting the variable an instance of dummy message class, and then I'm calling the dummy message function on whatever class implements that iDummyMessage class interface, and that will hopefully work now. So I'm going to save this, compile interfaces, works great. I'm going to even parse this just to make sure everything looks good as far as Rubberduck is concerned. It's pending, parsed, resolving interfaces. Okay, good. I think we're still inspecting, ready, pending. Come on, move it. Okay, we're ready. Now when I hit display message, same thing. I'm such a dummy. Again, seems like a lot of work for absolutely no reason, right? So check this out. Now that I've assigned myMessage to be a type of iDummyMessage class, whatever concrete class I want to use, it doesn't really matter as long as it implements the same members that are on iMessageDummy class, or iDummyMessage class. So I'm going to go over here and I'm going to create a new class module, and I'm going to say it implements iDummyMessage class. Okay, and once again I'm going to create my little function. This should be a public function. Again, another little bug in Rubberducky. I hope they get this fixed. But now I have a public function called iDummyMessage class dummy message. That should look familiar, right? That's the same function name that we had here on dummy message class, right? It's the same thing. We're defining the same exact member on this new class because we're implementing the same iDummyMessage class interface. Now, instead of returning what we had here where it said, I am such a dummy, instead, stop that. I'm going to say it returns instead, I am not, or I am not a dummy. Okay? And let's go ahead and save this class to be, I'm going to call this not dummy message class. Okay? So we have two classes, two concrete classes that implement the same iDummyMessage class interface. And now I can go back here to this subroutine, this display message subroutine, and instead of saying new dummy message class, I'm going to say new not dummy message class. Save that, compile, everything works. Okay, everything works. I just swapped out the class that's being used. I'm calling the same dummy message function. And now when I hit this, it says I am not a dummy. All right, cool. So what other ways could this become really useful? Well, let's say that instead of, on my display message function, subroutine, excuse me, instead of defining my message here, let's say my message as dummy message class. And instead of defining it inside of the function, as a dim statement inside the function, instead it's a parameter that gets passed in. And now I don't even need to set my message, because all that's going to happen is when I call this display message function, I'm going to pass in some sort of class that uses dummy message class. And now what I can do is I'm going to create another subroutine that says not dummy, or display not dummy message. And all this does is it's going to call, I need to dim a new instance of, let's see, let's say dim new message as, I'm going to say, it could be dummy message, that's fine, dummy message class. And we can set new message equal to new not dummy message class, and then we're just going to call display message, and we're going to pass into this the new message object. Okay, so I'm passing in, I'm creating a new instance of some sort of object that implements dummy message class. I'm assigning that new message variable an instance of not dummy message class, which again implements dummy message class. And I'm passing that object in as a parameter to the display message. So I'm passing in new message as a parameter to display message. It takes that inside as a parameter here, which again is just defined as an dummy message class. And then message box can then just display whatever the dummy message function is that's being passed in here. And now if I do this, display not dummy message, I am not a dummy. And now I can do this, public sub display dummy message. And I'm going to basically do the same thing here. I'm just going to copy this code for right now. But I'm going to change this from not dummy message to dummy message class. And I'm going to do basically the same thing. But now it's going to be display dummy message. Now it says, I am such a dummy. Now that is amazing. That is absolutely amazing that this function call, this subroutine here called display message, can take any type of class that implements dummy message class, which means that it knows, this function, display message, knows that there will be a function on my message called dummy message that will return a type of string. And as long as it knows that, I can code up to it, right? Now I can do debug.print my message dummy message, and I'll always get this nice syntax, this nice IntelliSense that comes with it. So now not only am I going to display it as a message box, but I'm also going to print it out here in the immediate window. I am such a dummy. So we've really given ourselves a lot of flexibility about what can be passed in. Instead of passing in just the one dummy message class, it could be, instead of just passing in a concrete class of type not dummy message class, okay, I would have to, it would be kind of difficult for me to call in, my message, this won't compile because we're not implementing dummy message class. It'll say that there's a problem calling that method dummy message, right? Because dummy message class. And then this function here of display not dummy message wouldn't work because it's trying to pass in an instance of not dummy message class, which doesn't match here. So you can see the versatility that's going on here by just saying, use the interface instead of a concrete class. That allows me to use different concrete classes and interchange them and be swappable and movable inside of my code. And based upon different criteria, I could call something different. I'm going to do one last thing here just to kind of show you. This could work with like a switch statement. So we'll do something like this. Public sub, I call it a switch statement because of my C# background, but you guys call it a case select statement. Select case statement. So I'm going to say select message, and we'll pass in a parameter. We'll just say is dummy as boolean. Okay, and now we'll do something like this. So we're going to dim an instance of dummy instance as dummy message class. Okay, and then we're going to say if is dummy, then else, and if. So if, then we're going to set dummy instance an instance of what's called dummy new dummy message class, and if not, then set dummy instance equals new not dummy message class. And now we can just call the display message, and we're going to pass in dummy instance. Okay, so now I can write this essentially out to be, and this could be a select statement instead of an if then else statement. You can imagine that if I was passing in a value that was something like 1 2 3 4 5 or some sort of string or something, and we do a select case off of that instead of an if. But this is a good enough example where if I'm saying whether or not I am a dummy being passed into this select message, it's going to pick one of those two instances of a type of class that implements dummy message class, and depending upon what I say here, it will set dummy instance variable to an instance of one of those two concrete classes, and then pass not the concrete class, but an instance of dummy instance, which is just a type of dummy message class, and pass that along then to this display message. So now I can do select message false. And when I do that, I am not a dummy. Select message true. I am such a dummy. Isn't that cool? Isn't that awesome? I love this. I love that we have interfaces and we have actual genuine abstraction. And this has much bigger implications. I just wanted to give you a very simple example to show you how this works. This has much, much bigger implications than I think you guys could possibly fathom at this particular moment, unless you've gone through some of the other object-oriented programming languages like I said, Java or .NET. So I'm stoked. This has such huge implications, and I hope you guys understand what some of those implications are. I hope that I've demonstrated how interfaces work in VBA sufficiently enough for you guys that this is going to blow your minds away. Such a big deal. I can't even, for 5 years I've gotten this wrong. I did not know. I'm sorry, guys. I really apologize. I feel terrible about it. Anyway, if you guys have any questions about this, which I'm sure there probably will be because this is such a new thing for all you Access coders out there, please drop me a comment in the comment section below this video, and I will be happy to get to those questions as I can. And always, if you guys enjoyed this video, please give me that thumbs up. Let me know that you like the video. Subscribe to the channel. Make sure you get the alerts whenever there's something new that pops up. Always want to subscribe so that you get those notifications. And also, don't forget, if you want early access to these videos, you've got to go to Patreon, patreon.com/programmingmadeeasy. And if you sign up at the $3 level, you will get early notification about these videos, and you'll get to watch them before anybody else. So that's a really big deal. You guys probably want to go ahead and do that. Anyway, I hope you guys enjoyed this video. If you did, like I said, hit that thumbs up, subscribe to the channel, and let me know what your thoughts are in the comment section. Okay? Till I see you guys in the next video, thanks so much for watching. Bye-bye.